So starting from this scene, let's create another geocontainer. We will call this fx, and inside here we will deal with the masks that will act as a source for our particle. So let's take an object merge and let's merge in the man. Now we want to remesh this whole thing, and basically the quad remesh right now works really fine. If I set it to 100,000, I have a pretty good topology as a result, but the spreading effect we will create is based on the points connected to each other. So in this case we want to use a classic remesh. So take a remesh node, and here let's set it to 0.1 for now. We want something like this as a topology. It will work much better with the spreading effect. Now, if you have some mesh like this with a lot of UV island, during the remesh operation you will encounter some issue. So basically this is my original setup, and I was doing this for loop where I was remeshing basically the pieces individually based on the UV seam. So I would get something like this. And I just discovered that this is not needed because the remesh has this button, harden UV seams, which will resolve all the UV issues. So this part won't be needed. And basically this is all the remesh we need. I will lower these sides to, let's say, 0.06. This will be our final target size, maybe even 0.05. So we have roughly 200k, and I need this on. We should have a little more points, yes. And now we want to cache this mesh as a BGO, so it will be lighter for calculation. And let's call it man remesh. We want to set it to explicit, not independent, and let's write it to job/geo/$os, so it will take the node name.bgosc. So save to disk. And we have the man mesh remeshed. And we will do the main workflow on the single mesh and then replicate it on the other. So the first thing we need is some point for the spreading effect to start. So let's take an add node, and you can use a scatter for this one, but I want to manually choose the starting point of the effect. So let's take also a group node. The cache will go into the left one, and here we want to disable the base group, enable in bounding region, and choose bounding object. And let's call this group start and set it on points. So now we want to take a sphere and a copy to points. And here we will copy the sphere on the points that we will create. Let's start by creating 1 point. And this will be on the right input of the group. So if we move the points, we can define, let's enable also the snap, because we need this to be on the surface. And technically we should see the points, the group, and we do. Let's change the sphere to polygon, and we want to take just 1 point with a single sphere. So let's say this point is right here. We want to change the sphere so in the group there's only 1 point. So let's set the radius to 1, and we will deal with the uniform scale. So something like 0.01, we do have just 1 point. And later on we will scatter more points on it. We will end up with something like 10 points per mesh, but for now let's just start with this one. Now we want to take a point wrangle so we can initialize some attributes before going inside the solver. So let's call this one init_attr. Inside here we want to initialize a mask attribute with the value of 0. An integer attribute we will call birth for the starting frame, and for now we want to initialize everything as -1, and also an fage as 0. Now, as I said, we will base our logic of the solver on the points connected to each other with this function, the neighbors one. And basically this function will give the list of the points connected on the current iterating point. And since our topology doesn't change over time, we can actually calculate this here before going inside the solver. It will be much faster. So let's create an integer array attribute. So e bracket at, let's call this near, and the function is the one with the final s, neighbors, geometry 0, current point number. So if I split the view, not like this, and check the geometry spreadsheet. So where is it? Inspector, geometry spreadsheet. Let's take, let's say this point, which is the 87607. There it is. As you can see, it has a new list. Let's filter this out. I just want to see the list of all these points. Basically, it does 1, 2, 3, 4, 5, 6 neighbors, and it checks out. You can see 7582. It's right here. And contrary to the near function, this one doesn't include itself, so we don't need to care to remove the first entry of the list. And finally, before going into the solver, let's create an attribute. We initialize the mask at 0 on all the points, but now we want to set it as 1 on the start group. So if we create a visualizer for the mask, we should see our single point here with the value of 1. So now let's drop down a subsolver and dive inside. Now inside here, let's take a point wrangle. This will be the expand, so we'll call this expand. And basically the idea is that each frame, all the points, we will transfer in an additive way the mask value to all of its neighbors. So basically we need to retrieve the mask and the neighbors list. So let's retrieve the mask. Float mask is f at mask, or rather let's call it pt mask so we won't confuse it. And then the list, so int near with the bracket because it's an array. It was e bracket at near. So we have the mask and the point list. And now for each point on this list, we want to transfer and add the mask of the original point. So we will take a for each, and for each int pt inside near, we want to do something, and we want to set point attribute on the geometry 0. The attribute we want to write is called mask. The point is all the points inside the loop, so each iteration will bind it to a neighbor, and the value is the pt mask we computed up there, and the mode this time will be add. We don't want to set the value. So if we go outside, we should already have something, and we do. As you can see right now, it gets weird as we move on. This is because we are adding more and more masks, so we need to clamp this value. We want to make sure it always stay between 0 and 1. So let's take another point wrangle here. We will call this clamp mask, and here we just want to clamp the current mask value. So f at mask is equal to clamp f at mask between 0 and 1. And this already fixed the issue. So now we have a basic expansion going on. What we want to do now is basically to create some sort of noise to this movement, because even if it seems it has a noisy edge, it's just the topology of the mesh, and even if it's just too uniform. So we want to basically create some sort of friction map so we can use it to drive the expansion. Basically we want to take a point bob, and we want to do it after the cache before going into the solver. Let's dive inside. Inside here we won't do much, we just want a basic noise. So take a turbulent noise, plug the position, and we just want to promote the roughness, and we want to use a sparse convolution one. Then take a fit range, so we can remap it from -0.5 to 0.5 and 0 to 1. And we want to bind export this attribute to a new one. I mean, we want to export this to an attribute, and we will call this fric for friction. So if I create a visualizer outside, I want to crank up the roughness all the way up to 1. So I want something like this. So basically, the spreading effect will move slower or faster depending on the values of this map. So let's rename this guy to fric, and we can go back inside the solver. So let me rearrange these nodes. And inside here we want to take that fric value, but we want to be able to remap it. So let's create another float variable. We will call this fric, and we want to fit01 the current fric attribute, which is this map, and we want to fit it between the CHF min and CHF max. Let's click here, so we have this pair parameter. Now, since we're using the neighbor function, we just have the connected points. So we don't have a real way to control the speed or the distance of this expansion. So we basically want to use this fric value to control how much mask do we pass to the neighbor points. So we want to retrieve this value. So let's float fric is equal f at fric. But we want to be able to remap this value, so fit01 between CHF min and CHF max. Click here, we create this pair parameter, and let's say minimum 2, maximum 4. Basically now we want to say that the mask that will be passed on the neighbor point will be the current mask value divided by this fric attribute. And actually we want to reverse the two parameters here, so first the max and then the minimum. Even if it may seem counterintuitive, since we are dividing, the minimum will actually output a higher value, so this is more correct in a way. So let me pin this parameter interface, go outside, and we want to visualize the mask again. And let's see what we done. And as you can see, it has a tiny little amount of noise. We want to increase this by a lot. So let's say 5 and 40. And now you will really see the difference. So basically, the points are deciding how much mask to pass to the neighbors. And as I said, the max value is actually outputting the smaller fraction, so it's actually this lower area. But as you can see, this is creating this nice spreading effect. And this will be the base mask that will drive the erasing of the mesh. And we need to compute another one that will drive the emission for the particle, because as it is right now, if we will use this to drive the particle emission, we will have a continuous emission on the erased area. We don't want that. We want a mask similar to this one, but that also decay from the center as it expands. And basically, whenever you need to make something decay, you need some age value, something that tells you how old is a certain point of particle. So back inside the solver, we need another point wrangle. We will call this calc age. And first let's create some life value. So float life, it will be equal to CHF life. And we want to multiply this for your FPS value, in my case 25. So if we set it to 2, basically the points will start to decay after 2 seconds. And we want to compute a normalized age, so f at age, it will be equal to clamp the current frame number divided by the life, and it will be clamped between 0 and 1. So if we create a visualizer for it right now, we should have some uniform aging on all the points that will reach the maximum at 50, because we set it to 2 seconds. So basically, to make it work, we need also some birth attribute. The problem is that we are not scattering point over time, so we can't really use something like create some birth attribute at the current frame, because all the points are present at frame 0. This is partially a reason that we set this birth attribute to -1, because this is like to say these points are not active. I mean, technically, this is not different than saying -64, like for example, but -1 is a value that you tend to use whenever you want to state that something is deactivated. A lot of function does return -1 whenever they can't compute their output, so this is a good convention to keep in mind. And basically our birth, let me display the mask again, our birth frame should be the frame when the point will reach the maximum mask value, meaning 1. So we want to drop down a final point variable. This will be calc birth, and in here we want to say if the current birth attribute is less than 0, and at the start it is because we set it as -1 for all the points, and the f at mask is greater or equal than 1, so basically when as reach is maximum, then what we want to do, we want to compute the birth frame, so e at birth is equal to the integer of the frame, and we also want to move the point to a group called aging, so set point group, geometry 0, the group we will call aging, the current ptnum, value 1 because we want to add it, and the mode will be set. And in here we want to execute this only on the aging group. So in this way we should have excluded, let me display the age, we should have excluded the inactive particles, and we did. As you can see, the aging is still uniform because we need to subtract the birth frame from here. So let's retrieve it, or subtract directly the attribute, doesn't matter, so e at birth, sorry, we need to give it a name, and here current frame minus birth, and put it between parentheses. So now let's go outside and let's see. And it seems the age is correctly working. We won't subtract the mask for the decay here inside the solver. We will do it outside, so it will be more controllable. But we're basically done with the solver actually. Now we can take an attribute delete, because we don't need all the stuff inside here. Let's see, we do have birth near, we just want to keep the age and the mask. Those are the two maps we care about. Also take delete group delete node, and we can delete all the groups because we would have the start and the aging, we don't need those. And if you want, you can do a cache at this point. I rather want to compute the final decay map and then do the file cache. So from here take another point variable, and in here we will overwrite the age, who cares, so f at age. First we want to remap it with a ramp, so ch ramp, we will call this age ramp, over the f at current age, and we want to multiply this for the other map, for the f at mask. So if you click here, by default we will have something like this. We want to reverse it, and let's just set the curve to be something like this. So basically this map will drive the emission of the particle, and this other the erasing of the polygons on the mesh. So this will be remap age, and we do have a small issue right now. So if we merge the original group delete at the age one, and let's take a color node, disable the visualizer, Basically we want to remap this, run from attribute, let's use the mask, and we want to set it to infrared, and do the same on this other node, but this time we want to remap the age, and let's take a clip node, let's set it to something like this. Right click, action, create reference copy. This will create an entire node with the relative reference, and we want to connect this to the right input. Don't mess the wires up, but we want to delete this channel and set it to the other side, so it will delete the opposite side. And basically this is all to show you that right now we have a little problem, because the border of the mask that will erase the polygon is right on the edge of the emission layer, and basically I want to shift this mask so the erasing will happen in the center of the emission, where we have more petals to mask the erasing of the polygon. So basically we want to offset just one attribute. So we want to take a time shift and plug it before the remap of the age. Here let's edit parameter interface. We want to add an integer channel. This will be offset, and also a name, apply and accept. We will copy this parameter, and here current frame plus paste relative reference. So basically now we can offset just this mask, and let's say we want to set it of 10 frame, something like this. So basically the erasing will happen more in a concealed way. The problem is that now we will start with this sort of thing because we offsetted by 10 frames. So we want to take another time shift, and also let's duplicate this one, so we already have the channel here. So this will be right after the group delete, and the second time shift will be after the first one. And on the first one we want basically to take the offset of the second one, so copy parameter on this branching one, and on the main one we want to paste relative reference but negative. So basically, and I believe we have to set it to clamp to both on both of the time shift. So now we will start with just a point compared to this thing. And if we are going forward, we do have the erasing on the middle of the emission layer. Now, of course, we don't want to separate mesh or this clip and color, so delete all of this. And we want just to take a point wrangle, so we can transfer to the main one, which carry the mask, the age layer. So here, f at age, we will take it from the other input. So point, geometry 1, age, current point number. And delete also this merge. So here we should have the mask and the age shifted. So let's take this file cache, and this will be our animated cache for the solver. It will take a few minutes to calculate, but whatever. So let's call it man source geo. And I don't want to output it to geo, and also we need a time dependent cache this time. I want to write it to cache, and also inside a subfolder with the node name. So $OS, and also the frame number, so .f4.bgo.sc, and let's save it. So it took only 20 seconds because it's just one point for now, but I can check that both the mask and the age are currently working. Now, before the final cache, we want to add more points that will act as the starting group. And all we need to do is just add points here, and this part is really up to you, so I will fast forward to my final setup. So I created 10 points for the man mesh, and I duplicated all the workflow we did so far with the other mesh. So this one, I remeshed, I file cached the remeshed version, and also established some starting point for this version. For everything else is just a copy of it. I didn't even modify the offset on the friction map, so to speak. So now I can rename this to woman source geo and save my final caches. So my cache is done. It was pretty fast actually, so we can merge both of those to check how it is going. And we are seeing the age and everything seems correct. Right now it stops like 300, so we could actually save 200 frame less. I mean, the cache is something like 2 megabytes and something each frame. I mean, it's up to you. If you want to save less frame than the whole time range, let's say you want to do something like 1 to 300, then you need to make a switch with a static frame, because this file cache doesn't have this option like on the time shift that it says when you don't have the mesh, just clamp the last or the first, so it will throw you an error. But anyway, I will keep it as it is, so I have my full range cached out. The only thing now, you may notice that we don't have UV anymore, because we deleted after the solver. That's because I don't wanted to save the UV, which is not really light, as an attribute, because it's a 2 vector on a sequence of 500 frames, so we did it on purpose. It wasn't a mistake, but now we have to retrieve it somehow. And since our point order has never changed, let's just take an attribute copy. So attribute where is it? Attribute copy. And we want to copy to our final cache from not this one, because we remeshed after it. So let's take an object merge that will point to the static cache, and this will be the source of the copy. Here we want to transfer the UV, which are on the vertices. So now we do have our maps and our UVs, and we need to do the same on the woman. So let's duplicate the copy and the merge. This will be on the left side, and here we need to replace the source with the woman remesh. Finally, let's just take a null. This will be out man source. This will be the source for the particle and also for the woman. So woman source. And basically we're done with the mask and the effect for the erasing. Now we need to deal with the particles.